Again, let's read the problem together. So the first sentence gives us some general information that this financial analyst named Brian Givens is trying to help some clients to decide how to invest their monies after they retire. And starting from the second sentence, so this specific client has $750,000 to invest when she retires next month. And Brian and this client are considering these 1, 2, 3, 4, 5, 6 bond issues to invest for this 750,000. Okay, and this table here gives us some general information. The first the second and the third columns give us the return of each bond issue and the years to maturity of each issue. They are pretty easy to understand as they are common sense. Okay, and for those ratings, this paragraph here gives us some explanation. So a rating indicates an independent underwriter's assessment of the quality or the risk associated with each bond issue. Okay, we're going to use these later. Now, this third paragraph gives us the main information about the restrictions. So first, Brian believes that all the companies are relatively safe investments. However, to protect his client's income, they decide that no more than 25% of money should be invested in any one investment. Okay, so that's a restriction, the first restriction. And at least half of her money should be invested in long-term bonds that mature in 10 or more years. Okay, so those long-term bonds mature in 10 or 1 years will be this one, this one, this one, and this one. These are the long-term bonds. Okay, so at least half of her money should be there. So that's the second restriction. Also, even though DEO offered the highest returns, it was agreed that no more than 35% of the money should be invested in these bonds because they represent the highest risk. Okay, so that's the third restriction regarding these three, no more than 35%. Then Brian needs to determine how to allocate his client's investment to maximize her return income while meeting the agreed upon investment restrictions. So this last sentence again is very important. That gives us two pieces of information that leads to two parts of our model, which is the decision part. How to allocate the investment and the objective, which is to maximize her income. Okay, so this is some basic analysis of the problem description. Okay, and I listed them here in some bullet points. Okay, so let's look at, so starting from the last sentence, let's decide what the decision variables should be. Okay, determine how to allocate the investments. So what does that mean? Determine how to allocate this 750,000 in these 6 bonds. Okay, that means how much money from this 750,000 should be in A, and how much money from this 750,000 should be invested in D, in E, M, O, and S. Okay, so that's the decision, how to allocate, how much money to put in each of them. Or how many percentage should be in A, D, E, M, O, S. Okay, and if we determine the percentage of the money allocated in each of those bond issue, then multiply this 750,000 will give us the amount of money that should be allocated in each bond. So either way works. And that gives us two ways of defining the decision variables. Okay, so we'll use the first way of definition. So our decision variables will be we need 6 decision variables representing the amount of money invested in these 6 bound. Okay, we can use x1 through x6, but also we can just use the first letter of each bound issue to represent the amount of money. That makes it easier and more meaningful. Okay, so I'll put the decision variables are A, D, E, M, O, S. Represents the amount of money to invest in bound issues A, D, E, M, O, S. Okay, so these are our decision variables. Then the second part of an OR model is the objective. So we come back to this last sentence again. We said the objective is to maximize the total income. Okay, so what do you think the income is? Where does the income come from? Income from any investment come from the returns, right? So for $1 that we invest in A, we will get 8.65 cents out. Okay, and then for every for every $8 invested in this bond, we get 8.65% times this A value. Okay, so that's the return we get from investing in bond A. Then with a similar format, we get those returns multiply the amount of money represented by our decision variables. Okay, so our objective function is to maximize the total return, which is 8.65% times A plus 9.5% times B plus 10% times C plus 8.75% times I'm sorry, I put ABC. Should be ADE. Okay, and M plus 9.25% times O plus 9% times S. Okay, so we've got 6 returns from investing in these 6 bonds. Some people may include the principals that are invested, but here we only include the returns here because we're talking about maximizing the income that are from the return. And if we want to know what's the total amount of money that this client will get after this investment, we just add that $750,000, which is the principal. Okay, so with this, we take care of the decision variables and the objective function. Now let's look at the constraints. Okay, on this problem statement page, we summarize the 1, 2, 3 restrictions, and each of a restriction represent one constraint. Okay, and they are listed here. So 1, 2, 3. 3 restrictions representing 3 constraints. And as we go through more of our problems, I hope you will develop the sensitivity that when you see those words such as no more than, at least, another no more than, you will see, oh, these are, you will recognize these are the keywords that represent a constraint will be needed. Okay, so here, no more than 25% of money should be invested in any one investment. So that means the money that we put in A should not exceed 25% of the money invested. Okay, and the money that we put in D should not exceed 25% of the total money invested. Okay, with the same logic, we're going to write the constraints here. So subject to the amount of money we put in A should be less than equal to 25% of the total money invested, which we assume it's the 750,000. Okay, and that's the same for all the investment. So that's A, D, E, M, O, S. So for all of them, they need to be less than equal to 25% times 750,000. Okay, and the one thing I want to note here is that a common mistake I noticed from previous students was that some students tend to write this constraint as A less than equal to 25%, which is wrong based on our definition, because our definition of the decision variable is the amount of money that is put in each of those investments. And if you don't multiply this $750,000 here, then the unit on both sides of the constraint will not be the same. Okay, so on the left hand side it's a dollar, amount of dollar, and on this side it's just a percentage. Okay, only when we multiply this $750,000, then this unit on both sides will be the same. So they will both be amount of money. Okay, so one thing you want to make sure, especially when the problem involves those percentages portions, you want to make sure that the units on both sides of your inequality are the same. Okay, so that's something to note to make sure you don't make the mistake. So I'll wipe this here now. Then let's check the other constraint. So this one is done. Check. Then the second constraint, at least half of the money should be invested in long-term bonds that mature in 10 or more months. Okay, and we've already identified it's these ones. That's A, D, M, and S. These are the A, D, M, S. These are the long-term bonds. Okay, so what this constraint is, what this restriction is saying that at least half of the money should be in A, D, M, and S. Okay, so the amount of money that we put in A, D, M, and S need to be at least the half of the portion. Okay, so at least, that means greater than or equal to half, which is 50% of the $750,000. Okay, so that's the second constraint. Then the third constraint, no more than 35% should be in bonds because should be in these ones because they represent a high risk. So DEO should not exceed, no more than, should not exceed 35% of the total. Okay, so DEO should not exceed 35% of the money invested. This takes care of the third restriction. Okay, Are there any other constraints that we need to put? Non-negativity may be one that you're thinking. Okay, so we need all the A, D, E, M, O, S greater than equal to 0. Okay, because we can put less than $0 in the amount, in the account. Okay, what else? Did we miss anything? So we checked these 1, 2, 3. All constraints are used, and those tables are used too. Here 750 is used when we calculate the percentage. When we calculate, they say like 25% or the 50% of this total. But look at this number again. This is the total amount of money that is available for the client to invest, which means we cannot invest more than what we have, right? Okay, so with that, we're saying the total amount of money that we put in all these 6 bonds should not exceed that $750,000. Okay, we cannot invest more than what we have. Okay, so now we have a complete model. But there is something I want to ask you. When we put this less than equal sign here, and you look at the rest of the model, see if this is a very accurate representation of all the requirements. So when we put, in other words, when we put this less than equal to sign here, we're saying we should not invest more than what we have. Okay, so there is a chance that we are not investing all the $750,000. Maybe because of this constraint, we can't invest more than 35% in these ones. Okay, so maybe because of that constraint, we're not able to invest all the money. So if we're assuming that we're not going to invest all the money, we invest no more than this 750, then to make the model more accurate, this part here, this 750 here, this 750 here, this 750 here, should be changed to A plus D plus E plus M plus O plus S, because that's the actual amount of money invested. Okay, so after changing this, think about it again. Because the 3 restrictions are saying, for example, the first one, we are not investing in any of the bonds for more than 25% of the total, and the total is represented by this sum here. Because of this constraint, there is a slight chance that we are not investing all 750,000. Okay, same with these 2 constraints. These 2 restrictions are saying that we do not invest more than half of the total money, or we should not exceed, and these 3 numbers, these 3 investments should not exceed 35% of the total investment. So using the sum of these decision variables to represent the actual amount invested will be more accurate than assuming than putting this 750,000 here. Okay, because of this constraint. Had this constraint been changed to be an equal sign, which means that we assume we're going to invest all 750,000, which probably is the truth, because all the returns of those funds are pretty high, and if this constraint is not really a bonding constraint, then we're going to invest all the $750,000. Okay, so if this one is changed to an equal sign, then these ones will be great, will be good to use, because we are saying we are investing $750,000, and these restrictions, like the total amount invested, is just 750. Okay, so this is one example of writing models in an accurate way, especially for modifiability purpose. Okay, later if some more constraints are added to this model that make this less than equal to constraint, not let's see, not how to say. Later, if more constraints are added, and which makes the left-hand side of this constraint less than 750, then A plus D plus E plus M plus O plus S will be less than that 750 here. So using this sum here will be a much better, a more accurate way to represent the total amount of money invested. Okay, so this is the model of this problem when we define the decision variables to be the actual dollar amount invested in ADEMOS. Okay, so here is a summary. That's we define the decision variables to be amount of money to allocate, and the maximization objective is to maximize total return. And we have first, we assume that we're going to invest all the money. So the total invested in all the bonds should equal to 750,000. Then no more than 24% will be less than equal to 25% of this 750. Another constraint will be 50% constraint. So these will be greater than this. And the 35% restriction. So DEO less than equal to these ones. And the non-negativity. So all the money invested should be greater than equal to 0. Okay, so let's go back to our model. What if now I'm going to use a different definition for my decision variable? Instead of defining them as the amount of dollar you invested, now I'm saying, okay, I'm defining my decision variables to be the percentage. Oh, sorry, let me change my. Yeah, I'll just use this blue color. Percentage of total money to invest in bond issues ADEMO. Okay, so now these decision variables represent percentage instead of actual money. Okay, how should we change our model to represent this change of decision variable definition? First, look at the objective function. Should the objective function to be changed? So now the ADEMOS are percentage, and these percentage numbers are returned here. So it's a return multiply a percentage, which gives us not really meaningful value, right? So let's multiply 750,000 here. Okay, then with this number multiplied, the objective function value is a meaningful number, which is still the amount of money being returned from all the investments. Okay, and just know that for this object function, with or without this $750,000 here, it will solve in the same way. Okay, because we are just multiplying. It's kind of like amplifying this objective function by 750,000 times. Okay, so it will still solve the same way. But we prefer, this is the preferred way to write this objective function, because when the problem is solved, the objective function value gives us a meaningful result, which is the total amount of money, total amount of income we get from this investment. Okay, so that's the objective function. Then the constraints. Now, our ADEMOS represents the percentage of money that we put in this six different bond issues. And so the first group of constraint is taking care of this restriction here. No more than 25% of our money should be in any one investment. Okay, so the percent of money we put in A should be less than equal to 25%, right? So now we are saying percent is less than equal to a percent. So back to that consistency with the units. Percent less than percent. So we just cross this 750 here. Same here. Okay, so we don't need those ones. What we are saying is the percent of money put in A should be less than 25%. The percentage of money put in D should be less than 25%. So all the percentage should be less than equal to 25%, which makes sense now. Okay, then same for these two constraints here. The total percent we put in ADMS should be greater than equal to 50%. Okay, so cross this one. The total percent of money we put in D, E, and O should be less than equal to 35%. Okay. What about this last one? The total percentage in all the investment bonds need to be less than equal to or equal to 100%. Right? So we want to make sure that we don't invest more than 100%. Okay, so again, this sign here can be less than equal to or equal to. And if it's less than equal to, then on the right hand side of those constraints, we need to multiply this sum of ADEMOS. Okay, or if it's equal to 100%, that is saying we are investing all the money. Okay, we're investing 100% of our $750,000. Then we don't need this we don't need this part. We just leave all those percentage on the right hand side. Okay, the only change will be the total amount should be equal to 100%. And we still need to make sure that those percentages are greater than equal to 0. We don't invest less than 0% of the money. Okay, so you see, this is the second way of defining decision variables. And because of this different definition, our model should be changed accordingly. This, again, illustrates the importance of specifying exactly what your decision variables represent so people can understand your model better. Okay, so that's this problem.